Good afternoon, everyone, and once again, warm welcome to this webinar on the industrial machinery. So, Beacon is conducting a series of webinars in this work from home scenario where you can learn a lot of things, new things, and you can also brush up on some series like knowledge sharing series for simulation analysis and other products as well. So today we are going to see what are the solutions, what SolidWorks can offer to the industrial machinery sector. So before starting, I just came across this particular saying from this great man, Dr. APJ Abdul Kalam, and I thought I can share this with you all in this webinar. So this is basically very apt for this point of time where everyone is going through one or the other problems. It can be personally or professionally. So it is now for us the time to keep ourselves together and get rid of this pandemic which we are facing, and by the end of it we'll all be victorious and come out of it in a well and good scenario where it will be fruitful for every one of us. So with this, let me just start today's webinar. The agenda for today's webinar is we'll just take a look at the industrial challenges of industrial machinery and what are the solution bouquet, what is the solution bouquet of SolidWorks, and we'll go to the initial visual roadmap. That is what we are going to see today, and followed by the solutions based on the CAD analysis and electrical, and then finally we'll see the final visual roadmap or the summary. So with that, so to start with our solutions, where SolidWorks has been in the leading in the industry for more than 20 years now, and there are a wide variety of solutions available for every aspect of engineering in any organization or in any sector. So to start with, every product starts up with a preliminary project or a concept. So now SolidWorks has a very powerful tool in the form of X-Shape and X-Design. These two tools are available on a cloud platform called 3D Experience, which was included into the SolidWorks family maybe 2.5 years back now. And X-Shape is a solution where you can do the complete subdivisional modeling, where you can build your concepts from the scratch. And then X-Design is a parametric modeling where you have all the capabilities of what SolidWorks can offer, but it is on the cloud platform. So there are much more very very well organized solutions or tools on the 3D Experience platform. You can go and take a look on our website, SolidWorks website, about this wonderful platform which can help you in all aspects. And as we all know, SolidWorks is well known for its CAD, and SolidWorks has always been a solution where it always pushes this parallel engineering process rather than a serial process. So in this, we have a lot of advantages, which we will see as we move on with the webinar later on. So for integrated mechanical and electrical design, we have SolidWorks CAD, PCB, and electrical tools, which are greatly integrated and provide a great deal of results. And once any design is done, then we go for the analysis testing, where we have the virtual testing scenarios. We have simulation, where structural simulation and flow simulation for your CFD, ECS, and also your plastic simulation for your injection molding components and molds. And moving on to, for any product to enter into the market, the most important thing would be, of course, the product itself, and again, how strongly it is marketed. So for this, we have a lot of technical communication tools integrated within the CAD, where a company can leverage the existing CAD design and create their marketing content or even technical communication tool, technical communication documents like user manuals and service instructions, animations, which go along with the product for installation site or even for any service personnel. So for when we talk about that, we have SolidWorks Composer, we have SolidWorks Visualize, which I'll be talking about a little later, And coming to the quality and manufacturing part of it, we have SolidWorks inspection. So inspection is a tool where you can create your first article inspection reports and automate the complete process of the documents that are required for an inspection to do. And the SolidWorks CAM again, which is integrated with the CAD, and SolidWorks MBD is one product which is which will be more keen on knowing the things. Where SolidWorks MBD is a model-based definition, where this is drawingless manufacturing technique. We'll talk in detail as we move into the webinar. And SolidWorks DraftSite is a homegrown product of Dassault Corporation. This is a complete tool for the 2D design that is very much required. Where you can do all your 2D activities, build your layouts, build your complete TWG, DXF files, which go for your manufacturing, which are basically your the documents that are needed for your manufacturing or production. So all these things can be completely created using DraftSite, which is again a very great product. And by doing all this, we obviously tend to generate a lot of data, that is SolidWorks PDM. I mean, data that has to be managed across the organization, across the departments, and it has to be kept in a place or stored in a way that it is easy to access when even after maybe 5 or 10 years down the lane of one project is completed. So for this, we have SolidWorks PDM to manage the complete mechanical or engineering data for rather. And SolidWorks Manage is a tool which is basically like your PLM, where you can do your process management, project management, item management, and dashboard reports, and you can basically distribute the resources. It can be your human resources, or even it can be your other resources which you require for manufacturing, designing, and etc. So last but not the least, the well-known product for communication is eDrawings, where you can directly open your SolidWorks models, your step files, or even drawings, and you can see whatever the design changes that have been taken place on the go, on the fly, on your mobile, or even on your laptop, without the need of SolidWorks. Basically, you can see all the design activities that have been taken place, and visualize, which is the rendering tool that is available integrated to SolidWorks. Earlier it was known as Bunk Speed. Now it is SolidWorks Visualize from 2015, and this is a great tool to give you the content which is required for marketing, even without following the traditional processes, and it will also keep you up to date. So this is just a small brief introduction of the bouquet of solutions what SolidWorks has to offer to any of the industries. Okay. And moving on with the industrial challenges for the industrial machinery. Yes, there are many challenges apart from this as well, but these four is something which is very much important. Shorter time to market because of the competition. Competition is very tough out there, and we cannot lose out time, and we have to be right on time and right at right place in the right time. So shorter time to market is one of the biggest challenges. And innovative product design, yes, this is again very key for the product to be a successful product, where design includes most of the hurdles that anybody can come across with the product. And cost minimization is again again very much critical to make more benefits to the company, and to give a better service at a lesser cost, where both the customer and the company can be in a winning situation. And the last but not the least, the reduced design cycle time, which is directly dependent on the cost part and the shorter time to market, or the time to market part of it. So reducing the design cycle time is the most important aspect, where SolidWorks has played a vital role in many of the industries and in many of our customer places, where we have given them tools, productivity tools, or any other kind of tools, which we'll see it as we progress now. And in today's webinar, these are the takeaways. These are the solutions that you will be seeing. We'll start from RFQ, like any other product. RFQ is the starting point for any business to happen. So, and then we'll go for the product development based on the customer requirements. Normally what we collect there, we'll be able to see the part design and productivity tools, detailing, some of assembly design and drawing, technical documentation. And I'm also very eager to introduce one very good solution called SolidWorks Cell. I feel most of you will be very much excited to see this solution. Okay, and followed by which we'll have analysis, simulation, we'll have structural simulation, and we'll see the most important thing, how to optimize your designs for better performance, and followed by electrical design, which is again CAD integrated, and we'll see the final visual roadmap at the end of it. So to start with, the RFQ process, and RFQ normally starts with a marketing or a sales guy, where they collect the information from the customer, and whatever the process is, whatever the product is required, whether it is made to order or whether it is a product which is already available. So let me, without any delay, in the interest of time, I'll just quickly move to the manage page. So this is the manage page, and anybody who is now well versed with or anybody who's familiar with the Windows platform or Windows Explorer platform, it'll be very easy for them to use. There is with minimal training, they can understand the complete workflow, they can understand the complete user interface, and they can start working with it. So here we have SolidWorks Manage. As I told, it's a project management and as well as a process management tool, where you can see where you can you can manage your processes. As this is one of the workflows what we have created for the BOM approval, design approval, project approval, and for starting from the RFQ. And pardon me if I'm a little bit fast, because we have only 1 hour, and there's a lot of solutions to be shown. And if you miss any of the things what I'm trying to say, you can always contact us, and we'll be more than glad to help you with it. So moving on. Here, as you can see, we have engineer to order, improvements, manufacturer to order, new product. So these are the different stages where an RFQ can start. So let us start with an RFQ request for quotation, where I can just go for the new RFQ requirement. And here I can just these are the number, this part number, description, and these entities will be automatically filled in once we give the information. And maybe the code is for something like a nebulizer or any of the product. These are the 3 products that I have created, and I've, just to show the workflow, I have created this. And then we can start giving the quantity required, and then who is the creator, who is the customer name, and other details that are required, who is going to prepare the code. So all this information can be added. So basically, I have prepared the code and the customer details. So in the customer name, I can just maybe I'll just use Swaglock, and automatically all the information will be taken place, and I can just send to the next stage. So this is a stage-by-stage process, and everyone will get an electronic approval, electronic message saying this is the task that you have, and we can go to the task as well, and take a look at what are the pending tasks upon my name. So for example, I can just save this, and then I can exit from this part. So once we have started the RFQ process, all I have to do is just go and see if there are any tasks that are pending. So let me just open this record. So once I open this record, I can just see what are the tasks that are pending. There are no tasks for now. I can just send this to the next stage, where a description it shows again to the user where it has started and where it is going, and what is the required documents that have to be put in place for the complete process to take place and go forward. And similarly, we have the workflows that have been created. I can just show one workflow for bill of material. where a bill of material, this is the bill of material workflow. If the bill of material is submitted, then it goes for approval, and when the approval, if anything is wrong, it gets rejected, and then it goes back to the person who has created for any changes. So similarly, we have the process for everything, and you can complete the integrated things within the organization with the manage and PDM well in place. So the advantages of SolidWorks Manage and PDM would be, you can manage your project and timelines and resources. And if you are if you are interested in the manage and the PDM, do let us know. We'll have a complete detailed demo on this, and you can streamline your essential processes like like creating a bill of material, or for any quote or an RFQ, or even a code submission to any customer. These things can be streamlined, and these things can be handled electronically. Okay, and we can maintain electronic part numbering so that there are no confusions. There are no confusions in the revisions what we create, and most importantly, this will help you to work in line with the industry norms and regulations. Say, for example, if you want to have an ISO certified company, ISO certified product, then these are the things which will be asked, or which will be, rather a product will be subjected, or a company will be subjected to follow some documentation processes, and all those things are covered within the manage and PDM environment. So next, well, let us move on to the part design and productivity tools. SolidWorks has always had strong design tools, and as I was talking about reducing your design cycle time, productivity tools have been very a very blessing in disguise for doing repetitive tasks, or the tasks which consume a lot of productive time. And then I would like to stress more on reverse engineering today, because we all know how SolidWorks is good in part design, and which is very common nowadays. Part design, drawing, creating a drawing, but out of the box solutions are more important. So without wasting time, let us go to SolidWorks. And today we are concentrating, or this is the design data that we have taken. This is OMAX Jet. This is a water jet cutting machine, and Omax is one of SolidWorks' leading customer in USA. They are pioneers in this water jet machining and water jet cutting tools. So as we know, SolidWorks is great, has provided great functionalities. When we talk about part designing, it can be sheet metal. When it comes to industrial machinery or any kind of machinery, sheet metal is is a very integral part of it. And SolidWorks has always provided the complete set of tools that are required to create any kind of part. Or it can, in this case, this is a sheet metal component. I'm just rushing through this. I'm not going to create anything. Okay, and here, as we know, for in any case of sheet metal, we get the complete cut list, which is automatically created by SolidWorks. And we'll have all the information that is required to create a cut list that is very much required for manufacturing. And we have flat patterns that are created. We can give the complete information about the material and to find out the mass properties, okay, and so on. So let me not rebuild, but I'll just quickly move to the mesh data, or the reverse engineering part, which is again picking picking the pace very fast, in a very fast manner, where working with this 3D data or 3D mesh files is becoming more common nowadays. And SolidWorks has given a lot of importance to this emerging trend of working with the mesh files. It has a wonderful tools that are available. So I would like to show just one small example. This is a mesh file, and so mesh file, when we import a mesh file, we can import a wide variety of mesh files like STL, OBJ, etc. And once we do it, we can see the mass properties of this particular part, and what is so we can also not only see the mass properties for a solid part that is created in SolidWorks, but also we can see mass properties for the mesh files, which is very much again required. So we have the direct modeling capabilities or the mesh modeling capabilities like any other SolidWorks CAD model, where we can directly use the native features on the mesh model. So in this case, and you can also convert it to convert to mesh body. Any solid body can be converted to a mesh body to work with them. And here, as you can see, there is a lot of data that is available with this mesh body, right? There's a lot of facets that are available, and if, for example, this has more than 18,000 mesh facets, so this will be a little difficult for any computer to any computer or workstation to optimize the performance and give you a better output when you zoom, pan, rotate, and work with it. So for that, we have something called as decimate mesh body. So this helps you to reduce the number of facets by percentage and simplify your mesh body or the mesh file. So give you a better performance and to use the minimum resources of your workstation or a computer for that matter. And once it is decimated or once it is simplified, you can directly start using the surface tools, which are very much very native, and you can start using the tools. We'll just see with another example how we can use the surface tools. And once we create the body, right, once we create the SolidWorks body from the mesh model, and it is always very much necessary to cross check whether the model and the mesh file are the same, or is there any deviation in the engineering or the design. So for that, now you can easily compare two bodies with the mesh file, one with the mesh file and one maybe with the SolidWorks created model. Okay, so once we select the model, let me just select it. Yeah, so once we just select the model, you can see that it will give you a color coding where this color coding or the graph shows you wherever there is deviation. So you can see that there is a deviation from the mesh model and the SolidWorks model. As you can see, there is a small cutout there that is available, but in the SolidWorks model, what we have created, we have not created a cutout. So with this, we can compare both the bodies, and we can be sure that whatever we have created, we are on target. Okay, and we have there are no discrepancies in that. So once we do it, we can take the help of native tools. As I told, we can create the complete body out of it and create a manufacturing drawing as well. So the next would be when we talk about the mesh files or any other files for that matter, like an OBJ, we can directly use the direct editing tools, normally what we use in SolidWorks, where if you want to have remove any holes or any part for any feature for that matter, where you use a direct editing tool, you can directly use them on your mesh models right now. And you can also use your surface tools where you can use the complete modeling capabilities for native CAD, how you use it. So moving on. So moving on with the part design and productivity tools. The productivity tools, we have a lot of productivity tools, like where you can, whenever you are creating any surface component, where you can do the thickness analysis or undercut analysis, and you can be sure of what you are creating. And I mean, before going even to the manufacturing and finding out any defects, and then coming back to the design part, you can directly do some basic analysis or basic tools, use the basic tools, and you can use it. So from the part design and productivity tools, you can simplify and streamline your workflow. Powerful reverse engineering tools and mesh modeling tools. Even I know that we are not shown in complete the capabilities, but if you are interested, please do get back to us. We'll be more than happy to showcase the complete thing. And numerous productivity tools to boost the efficiency cycle time. And when it comes to the manufacturing and drawing, let me just take you through one small component. So this is a component, and maybe you might be knowing about SolidWorks API, and where it is where we can create a small programs to create repetitive tasks or mundane tasks that we normally do. Okay, and here I have created one small API to create automation for drawing. So for this part, I can all I have to do is just click on the button, and I can just create the drawing. So I can just choose first angle projection, or the second angle projection, third angle projection, sorry, and it will automatically give us the complete information. And if I want to create any section views, so I can just start taking the section view in this. in this way, and I can just start creating the manufacturing drawing that is very much complete. So these kind of tools, these kind of automation tools are also available in SolidWorks, which will save a lot of time. When you are working, and increase your productivity time. Okay. Let me just take you through a few more things. In the interest of time, we'll not be able to cover most of it. Okay, please do get back to us on the mentioned. Finally, we'll give you a email ID of our personal email IDs, and you can just get back to us. So MBD is again a technique where you can do the drawingless manufacturing, practice the drawingless manufacturing technique, and you can create high quality and impecable manufacturing drawings. So model-based enterprise approach can also be used, or it can be practiced for if you are using smart manufacturing techniques. Highly detailed outputs can be produced in the form of 3D PDF and e-drawings from MBD. And when it comes to assembly and assembly drawing, working with large assemblies is very much at ease now in SolidWorks. Where if you see this complete assembly has around 6,000 to 7,000 components, and it can be easily worked out whenever we are using. Okay, and so we have created. So normally when we talk about large assemblies, we come across very huge data, the very huge files of drawing, right? So that is very much what happens is it becomes very difficult for the people working on large assemblies to open these drawings without opening the complete assembly file, which normally if it is used, it would earlier take around 3 to 4 minutes minimum, depending on the file size and other resources, arguably. Okay, and SolidWorks now has something called as the different modes to open a drawing or a complete model, where it is a detailing mode, lightweight mode, or quick view mode, or resolve mode. So detailing mode is one such very important tool, where you can directly open your very large drawings within no time and make some editings like adding annotations, notes, balloons, and etc., and printing, saving, so etc., for that matter. And even without opening a drawing, I mean the complete model, you can directly open this particular drawing there. So while it opens, let me take you through the different solutions what we have, what I had planned today. So assembly and assembly drawing, we have a lot of mates, very intuitive workflows for creating your mates, like you're creating your automated bill of materials, and automation tools like DriveWorks Express. I would like to show an example if time permits later. And SolidWorks 3D Interconnect is one tool which is very much important and very much advantageous to the users with multiple CAD environments, where they can directly import their multi-CAD environment, multi-CAD data, and you can start working on it where like a native SolidWorks file, and you can incorporate them with the SolidWorks assemblies. So here you can maintain the referencing with native CADs, where whenever there is a change, you can observe that there will be changes updating in your SolidWorks assembly file as well, and you can also import your custom properties. So 3D printing SolidWorks as a complete solution where you can be supported by the 3D printing options. For example, the pre-processing and the post-processing of a part, where you have to see the slicing of the component, and then if you want to see how it fits in the bed of the component, bed of the 3D printer, of course. And if it is not, and how you can orient them. And you can also we have a large comprehensive material library of the 3D printers available now, and you can select any 3D printer that is required, and you can start creating the things that are required for the 3D printer, like the 3MF file can be directly sent to it. And working with the 3D, staying with the 3D printers, now we can also convert without converting it to STL or any other files. We can now use it and send it directly to 3D printers via 3MF, which is the industry standard for additive manufacturing. Okay, so with that. So with that, we can also create slices where you can be sure of the layers and the number of layers that are required. You can do your you can also use your create sketches from the 3D models or the 3D mesh files. Maybe in coming webinars, we'll definitely take a session on how to work with the 3D mesh files. And finally, let us coming to the technical documentation. We have SolidWorks and Composer, where you can create your user manual, service instructions, and marketing assets. I have a few examples, and these are a few images that have been created using Visualize, which are more than realistic. Even the real machinery will not look so exciting and so informative in terms of colors and in terms of contrasts. So this is one example, other example of the complete tilt-a-jet machinery. And here is one more example. So technical documentation, I would like to show one small example where this is a composer example where you can create interactive content or even animations which with no words and no need of text, which are pages together, which will normally bore a reader, or it will not give much of an impact, or it will be very hard to grasp the information by the reader. So with the interactive animations and images, these things can be conveyed in a very neat and a very tidy way and more informative way. So all these things can be created inside the SolidWorks Composer for your marketing and even the internal consumption, like your user manuals, field engineers, and educating the users. So many things. And you can also reduce the resources required for your trainings and the materials and the personnel that are required. And with similar with Visualize, you can create HD static images, 4K animations, and AR and VR outputs. So finally, what I was talking about is SolidWorks Cell. So SolidWorks Cell is a 3D configurator which will help you to create. This is basically a cloud model where you can directly go to create these variations of your model, and you put it on your website, and your customers can easily see and customize whatever it is required by them. So this is the website of Omax Abrasive Water Jets, and SolidWorks Cell is a platform where we can create create on-the-go rendering, and we can see the complete information. So this is what I was talking about. So SolidWorks Cell gives you the ability to customize whatever is required, like the safety door, whether you want a pedal or you want a button. So if I want a button, it will automatically give me the complete design change of how it looks, and when it comes to the door, what is the color that your customer needs. So all those things can be done, and you can see it is a completely rendered model. It is not just an animation. I mean, it is not just a graphic body or anything. It has all the information that is available, and you can see that it is a complete 3D model. So SolidWorks Cell is basically and these are the different parameters what you can customize, and you can see. So SolidWorks Cell, coming back to it, it is not only your 3D configurator, which saves you a lot of time, a lot of resources that is required. It is also it comes also at an affordable operational expense. It does not require any hardware, external hardware. And it is a SaaS model. It is being given as a SaaS model, and it is out of the box solution where it can be completely or fully customizable to a brand exclusively. And we have different people already using SolidWorks Cell to now make it more interesting to their customers. And it is not only about configuring and showing your configuring your assemblies and showing it to your customers, but it also can help you to analyze how your customer traffic is there and do the data mining. It has also inbuilt data mining or analytics available, where you can track your customers feedback, what is the customer more interested in, and which product is getting more views and more likes and more orders, and all those things can help you to streamline your business as well as your production. So with this, I know this was a very fast session. I'm sorry, because of the time we had to do this. So if you have any doubts, we'll catch up at the end of the session for a Q&A. And now I would like to ask my colleague, Mr. Srishel, to take through the simulation part. Okay, and Srishel, I'm making you the presenter, and thank you everyone for bearing with me. Srishel, you are the presenter now, and hope you are, yeah.
Yeah, is my screen visible?
Yes, you're good to go.
Yeah, thank you. Once again. Yeah, thank you once again. I would like to thank each one of you for joining this webinar. Prithvi has explained in brief about the more productive tools that are there in SolidWorks, and next I'll be taking you through the design validation solutions which we have in terms of virtual SolidWorks simulation. My name is Srishal, and I'm an application engineer in Beacon, Bangalore. Let us first understand what are the major challenges that we face in terms of designing and developing any machines, any industrial machines. Some of the challenges has already Prithvi has explained, like it is very complex machines, and it is very expensive to make any changes once after you building this kind of machines. So and you have to make sure that all the components which you use in this particular complex machine should work as per your requirement, so that you will be not wasting your time and money on developing this kind of a products. So you have to also take into account that your machines will be working in adverse environment. There will be a lot of heat generation, there will be a lot of vibration environment, and last but not the most important, you have to reduce operation cost, for which we have something called optimization techniques. To address all these challenges, what I explained in a previous slide, we have a virtual validation tool called SolidWorks Simulation, which helps us to validate your design in a very beginning of a new product development process, in terms of analyzing its strength, in terms of taking into account of your heat generation rate, in terms of calculating the thermal stresses developed, and it also accounts for calculation of warranty of your product by calculating a fatigue life of it, and it will also addresses resonance and various vibrations that are present when this particular machine is under operating conditions. And the structural optimization, which is very much important, very much easy inside SolidWorks simulation, to keep your product to a minimal weight without compromising on the quality of your end product. Okay, without wasting much time on these things, let us start with the capabilities of a SolidWorks simulation in terms of a strength analysis. Let us first understand what is this strength analysis is all about. When we have a lot of components inside this particular complex machines, they will experience a lot of load in terms of a structural load, in terms of a thermal load, and in terms of a dynamic load, and so many loads will be coming onto the structures that are present in this particular complex machine. Okay, basically the strength analysis helps us to find what all the stress hotspots, what is the factor of safety, and it will also tells whether our design is over designed or under designed. So let us take this particular example, that water jet machine, which you have seen in the CAD presentation. I will just take this structure inside that particular machine, and we will do the analysis for this. Okay, this is a basic graphic user interface for SolidWorks, which Prithvi has already explained. And simulation, flow simulation, or any design validation solutions are just adding to your CAD systems. That is nothing but you are not switching between the windows to do 3D modeling and to do the simulation. That means there is a very good integration between your CAD system and simulation system. The moment you make any changes to a 3D model or any assembly, which is automatically updated in your simulation study. All we need to do is, in terms of a linear static analysis, you just have to go here and define the material properties. You just have to specify what material your components is made up of. There is a very good material database inside SolidWorks simulation, which contains all the important properties which are required to do the simulation. All the commonly used engineering materials are there. You can even search here what material you want. You just have to select and apply the material properties to as a starting step for the simulation. Once after applying this, the automatic context, since this is assembly, the connection between each and every part in this assembly is very important. SolidWorks simulation helps us to automatically detect all the contacts, whether they are perfectly welded, whether they are bolted, whether there is a pin connections, or whether there is a spring connection. All these connectors can be defined, and wherever the direct face-to-face contact is there, SolidWorks automatically recognize them as a bonded contact. Okay, you need not have to go here every time and do the manual contact definition. This is automatically taken care by SolidWorks. And after defining that, you just have to define some boundary conditions. That is nothing but arresting the degrees of freedom, because since this particular assembly is in a space, it has got 6 degrees of freedom. We just have to fix it. Fixing is nothing but virtually defining how exactly this component is going to work in your real scenario. So this is where the foundation boards is going to come, and that's why I'm taking all these 4 pieces and I'm fixing it. And once after doing that, I have to apply certain loads, because the strength has to be checked by applying action loads. First of all, the self weight itself is very much important. I'll take gravity to take into account of self weight of this particular structure, and then I will make use of a distributed mass, because this particular face is connected to some of the masses at a certain distance. I'll just take that locations and I'll choose the faces where the load is being transferred, and I'll apply the magnitude of the load. I mean, magnitude of the load as a 25 kg. Okay. Similarly, when this particular water jet is in a working condition, a lot of heat is being generated. We also have to take thermal effects into account. I'll just make use of a thermal boundary conditions here. I'll apply the temperature as a thermal boundary condition. That's it. This is about applying the boundary conditions and applying the loads, and automatic mesh is being created using SolidWorks simulations, and the excellent post-processing features inside SolidWorks simulations help you to quickly visualize the results, such as what is maximum deformation that is coming onto your structure, what is the stresses that are coming onto your structural members. There are some beams also present. To check their stresses on the beams, all you need to do is you just have to go to the beam force, wherein you will be able to calculate what are your beam forces, because beam is a 1D element. The forces, moments, torques that are coming onto that particular beams are very much important. Here you will be directly get all these values using SolidWorks post-processing features. Similarly, you will be able to calculate stresses on your each beams. Okay, here similarly the beam stresses, like your beam forces, all your axial load, bending stress, torsional stress, and worst case stress, everything is being automatically calculated using this post-processing features. And one more post-processing feature I would like to show is the reaction forces. Since I am adding a foundation bolts at this particular locations, I need to understand how much load is coming on onto this foundation face, so that I will be able to choose the right amount, right quality of a foundation bolts to hold this entire load. Okay, these are the for loads that are coming onto my foundation face. I need to keep all these things into I need to take all these things into account to design this particular type of components that is present in your complex machinery. Here are the results which I have shown you in the post-processing features of SolidWorks simulations, like what are the stresses that are coming on beams, what is the reaction forces, what are the beam forces which are present in my assembly, and what is the beam stresses. And basically the strength analysis in SolidWorks simulation is very easy to use, and there is a very good integration between your CAD system and your simulation system to calculate stresses, factor of safety, and you will be able to see whether your product is over designed or under designed by plotting the factor of safety plot. Moving forward, when we see this particular machines, all these structures will experience repetitively applied loads, because only strength analysis is not sufficient to decide upon the it's not sufficient to decide upon the life of the this product, because a lot many vibrations will be generating. There are a lot of rotating components are there. They will repetitively applied loads for that. it is also important to consider the factor of fatigue analysis, because so many applied loads are repetitive. We need to define SN curve for that, and SolidWorks simulation is capable of calculating total life cycle of for your product. For example, I have done a fatigue analysis for this particular assembly. All I need to do is we just have to define a SN curve. Again, SN curve is basically a material property, and we just have to define it using with a simple definition as a SN curve, and then you just have to define the event. Event is nothing but you just have to give whether your load is fully reversed, or it is only tensile or only compressive, or if you have any loading ratio, you can directly enter that here. Okay, after entering, you just have to solve this, and you will be able to get life of your product. From this, you can prepare basically the service manuals. Let us say, for example, after so many cycles of load, this particular member is going to, the crack is going to initiate on this member, and after these many cycles, we can take some preventive actions to, prevent the catastrophic failure of that structures. Similarly, as I said in the beginning of my slides about the challenges of challenges in industrial machinery, there are a lot of rotating components are there. They will generate a lot of vibrations. We also have to take into account of these vibrations into consideration to basically design this particular industrial machines. So the frequency analysis is one basic for all kind of a vibration analysis. It basically calculates resonate frequency of our structure, and by doing this analysis, you will be able to see whether my structure is capable of holding those many vibrations, or whether I need to add some extra stiffness, whether I need to make some design changes before proceeding for the manufacturing process to basically avoid the failure of your structure due to vibrations. Here are some of the examples wherein I have extracted the mode shapes of first three resonate frequencies. And here is one more example on machineries. The first three modes of vibrations have been captured, and I just put it here. So vibrations are always very much important in terms of designing complex machines like industrial machines. Okay, and when you see only static analysis is not sufficient for this kind of applications, we also need to understand what is the difference between static load and dynamic load. And to consider the effect of a dynamic load, we are having a very good solutions in terms of your frequency response analysis, like your harmonic analysis, random vibration analysis, the shock vibration analysis, to basically understand what if your structure meets the resonant frequency. What are the dynamic stresses that are going to come onto your structure can be evaluated using vibration analysis capabilities that are present in SolidWorks simulation. And here are the some of the examples on harmonic analysis. You'll be able to see basically the bending mode. The 15 hertz is a bending mode at which the maximum stresses is coming around 500 megapascal. These are basically dynamic stresses, which we also have to take into consideration when we are our structures are working under vibration environment. And last thing which I would like to cover in SolidWorks simulation is the structural optimization. It is very much important in terms of keeping your total mass of a product as less as possible without compromising on the quality. So we have got two types of optimization techniques in SolidWorks simulation. One is your parametric optimization, and another one is a topology optimization. First one is parametric, wherein you just have to define your variables in terms of your dimensions. Let us say, for example, I want to vary the dimensions of this particular component. I just have to define them as a variable. Then I'll be having my constraints. Let us say for constraints, my minimum factor of safety should be 2, like that. And the goal would be like reducing the total mass without compromising on the quality. And if I give those many inputs like variable, constraints, and goals, I'll be able to get the optimal value for my inputs that I give to the SolidWorks simulation. Here is a small example. This is basically just a small component which is present in industrial machinery. I will be able to reduce the mass of this by 10%. If you just imagine for a small component like this, SolidWorks simulation has helped to reduce the total mass by 10% for big assemblies and complex machines, even you will be able to reduce a lot of masses without compromising on the quality. And the next optimization techniques is basically a topology optimization. Here I'll be not having any variables in terms of a dimension. This is basically a shape optimization techniques. Here is an example. I just wanted to now optimize the design of this. My objective was to basically reduce the mass of this the frame by 30% without compromising on the quality, but I don't know which dimensions to vary. But my overall dimension has to be same, but I have to reduce the mass of this particular component. In topology optimization, it has suggested me to put certain pockets here so that your mass will be reduced by 30%. This is how SolidWorks topology optimization or any parametric optimization helps me to get a very good stiffness and very good strength to weight ratio, which is very much critical for any product development. So basically, the SolidWorks simulation or any optimization technologies will help us to keep our total weight as less as possible, which basically requires less energy, less electricity, less fuel to run that particular mechanism, to keeping the operation cost of your machines at a lower cost, which is very much important in today's scenario. With that, I would like to summarize the capabilities of SolidWorks simulation in terms of a structural analysis like static analysis. We have got motion analysis to take into account of your kinematics and dynamic loads, and we have got various capabilities like bolt weld connectors to check basically the weld strength, connector strength, pin strength, and so on. And we have seen the natural frequency analysis, and we have seen dynamic analysis capabilities with the design optimization. And in terms of nonlinear analysis, we have a nonlinear dynamic analysis to deal with nonlinear materials like plastics, rubber, and so on that are present in the industrial machines. We have capability of explicit dynamic analysis in terms of drop test simulation. And we also have a CFD analysis to address internal flow simulation, external flow simulation, and also the thermal analysis for your electronic equipment. This is a complete product matrix of SolidWorks simulation. We have structural analysis, we have CFD analysis, and the plastic mold flow analysis in our SolidWorks portfolio. With that, I would like to conclude my session on design validation, and now I will be handing over my session to Sindhu. She will be taking you through the ECAD and MCAD integration. Sindhu, I'll be making you a presenter. Over to you, Sindhu.
Yeah, thank you, Mr. Shishel.
You have to accept my presenter. This thing.
Yeah, just a moment.
Accept my invitation.
I did not receive it. Yeah. Hi all, good afternoon. I'm Sindhu, application engineer for electrical and PCB suite of products. As we all know, industrial machinery not only lies with the mechanical CAD, it is also important to know about the electricity, how the electricity is being provided, how the cables run, and also some of the electrical parameters, how they are involved within the mechanical system. So today, let's see how SolidWorks Electrical will help us in bringing the designs done. So this is the following agenda, what will be following in next 10 to 15 minutes. So first, let's see the typical industry machinery. So as we all know, the machineries will be set up, and then for that which we'll have to do the cabling and wire harnessing to that. So let's see what are some of the design challenges what we face in the industry. So first thing is manual wiring. That is, we need to wire the number the wire If we have like thousands of wires to number each and every wire, it will take a lot of time. So which is also cause the duplications. It is not that all the wire numberings will be correct. As we are humans, it is like there will be few errors. And also the symbol or the library plays the important or the major role in any of the tool. So even here, if we do not have a particular symbols which are assigned or which is listed, we need to create the symbols for the respective component, and then we have to assign it with the connection points, and then we have to proceed further. Next comes the terminal strip designs, that is the wire or cabling details which needs to be matched over all the process. Next comes the cabinet layout, where we have to check the sizing of the components and also the positioning, which is important in any of the system. And at last comes the bill of materials, where based on the components placed, based on the terminal symbols which are assigned, and also the ferrule numbering, that is the wires or the cables list, everything will be listed in the bill of materials. If any of this goes wrong, even in the bill of materials, the same error will be reflected. Also, we need to check whether the quality, that is impacting design cycle, if it is proper. So if we make any of the changes, then we have to redo or recheck the designs, and we have to get the proper design done. And at last, once everything is done, the time consumed, everything is just checked, last comes the project cost based on the errors, how much we have committed, and then for the final project, what is the time consumed, all this other some of the challenges which will be faced to get the final product done. So let's see how SolidWorks Electrical will help us in bringing or decreasing the design challenges. So here we can see in SolidWorks Electrical, we can get the automatic ferrule numbering. So we need not go for each and every wire and start to number. Or SolidWorks Electrical will automatically give the wire number based on the formulas assigned. And also SolidWorks Electrical has enhanced component library, where it will provide the symbols for not only the control designs, it also provides for the hydraulics, pneumatics designs as well. So you can create your hydraulics and pneumatics designs in SolidWorks Electrical. And then comes the terminal strip, where as I have communicated with few of the electrical designers, they have told that it requires almost 2 to 3 days to get the terminal strip design done. So here in SolidWorks Electrical, you need not do the terminal strip design. It will automatically get you the terminal strip design based on the terminals placed. And then comes the cabinet layout, where we have the symbol library for the cabinet or the 2D designs as well, where you just need to place the component based on the position, based on the overall component size. We need to just position the components in respective positions. And then comes the data synchronization, that is to check with the connectivity with schematic, cabinet, as well as 3D component, whether the particular symbol placed in the schematic is present in the cabinet layout, and is the same 3D component is present in the mechanical platform. And then comes the real-time DRC check, that is which we take look through the schematics, whether a few of the design rules, what the electrical engineers will look for, whether it is maintained, so that there is less of rework, where you will get to know where are the errors, so that you can just cross check and recorrect it. Then comes the dynamic integration with the mechanical CAD, that is how electrical with the integration with CAD works easy to get the products done. So this is the typical electrical design process, where first thing what any electrical designer does is schematics. Once the schematic is done and cross-checked, next it goes to the 3D, where they will check for the placements, and then we do the routing. Once the routing is done, after knowing the cable length, everything, it goes to the production team, giving all the data which are accepted or acquired from the schematic as well as 3D. So now this is the setup for which this is the IEC stretch wrap machine, for which we are going to see how we can do the schematic in SolidWorks Electrical and how the routing could be done with the help of MCAD and ECAD. So the design flow goes like this, where we'll first look into the symbols and wire creation. Then we'll look through the terminal step and PLC designs, as well as GA drawings. And then we'll see how the two tools communicate together and get the collaboration done easier. And then we'll see how the reports and documentation helps us, how we can get the reports and documentation. So this is the SolidWorks electrical platform. So here you can see we can do the single line diagram. We can also carry out the control. So this is the single line diagram which we can carry out. Even for this, we have a library which are linked here. So this is the schematic which we have. So as you can see here, we have a symbol library where there are different categories which are assigned here. There are different classifications as well. So here you can filter based on the classification. So as you can see, we have contactors, electronic components, and then we can also see the pneumatics and hydraulics. As I said, we can do this designs as well. So for now, let me try to add a motor over here and get the connection done. So here you can assign the manufacturer parts as well. So as you can see here, we have a library for the manufacturer parts as well. So we can just select the particular manufacturer part from the library and assign it. So as I told, these are not just the dumb wires. Here you can check for the properties. Also, you can assign the formulas based on which the wire starts to number. As I told, ferrule is one of the major problem in the electrical designers. So within just click based on the formula, the tool itself will generate the automatic ferrule numbering. And also, if there is any design which needs to be continued in the next sheet, we also have options where we can assign the origin and destinations. So here you can see with the help of origin and destination, you can choose the wires. So here it is not, I am not able to choose the red colored wire because of the formulas which I have assigned. So here, this is one of the important, this is where SolidWorks Electrical plays important role, where you can minimize the error which we commit. So you can just double click so that it will take you through the sheet where you have connected. As I told, we can also do the PLC designs. So here you can see we can add the PLCs. We can automate the PLC design, as well as we can do the manual PLC designs as well in SolidWorks Electrical. And also, as I told, we can add the terminal strips to our designs. So here you can add the terminal strip to our designs. We can generate the terminal strip drawings. We can automatically generate the terminal strip designs. So here you can see this is the detailed terminal strip drawing. And also, as I told, we can do the 2D cabinet designs as well. So this is the 2D cabinet design where I have placed the components based on the position. I can place the component and have a look in 2D as well. So once the schematic is done and the 2D cabinet designs are carried out, the last process is routing. That is to check the components in 3D, how it is positioned, and then doing the routing. So here, SolidWorks Electrical helps us to get the routing done automatically, where we can do the we can route wires, cables, and also we can do the harness designs over here. So here you can select a particular component and you can carry out the routing. So whichever the wires color, whatever it is placed, and whatever the properties the wire has got, or whatever we have assigned in the electrical 2D, the same thing will be carried out here based on the diameter, color, and also the bend radius which is assigned to it. So here you need not do the manual routing. SolidWorks, along with the help of SolidWorks Electrical 3D, will allow you to route automatically based on the, just we need to specify which components we want to route, or if you want to route the whole of the component which are placed, we can just select all the components and you can start to route. And also, as I told, we have the design rule checks which are present in SolidWorks Electrical. There are few sets which are already present. You can just add it over here based on your requirement. Like if there is any part which is not assigned, there are descriptions also. You can just go through that, whether if there is any empty terminal steps, all those you can check in, and you can just check for those design. So here you can see these, there are some faults in these all wires, so I can just go through that and I can correct the designs. And also here we have the reports. So here you can, as you see, even here we have few set of lists which we can get the bill of materials done, like list of cables or for the manufacturer's wire list, or tags if you want, or if you want to know the input output of PLCs, you can get that. Also the terminal strip parts based on the bill of materials based on the reference, all these are listed. So you just need to select which all you require and you can generate the outputs. So here you can see for this particular component, based on the EW path which I have specified, like, the routing is done. So similarly, have done the routing for the other components also. So you can see based on the diameter which is linked, the routing could be done automatically. So the same thing will be updated in the assembly as well. So here you can see how the cabling is running through the motors and other machineries. So with this, we get to see that how SolidWorks Electrical has few of the benefits, like how it will reduce the manufacturing defects and also the scraps. Also eliminate the hidden cost, where SolidWorks Electrical also provides you the length of the cables and wires based as it is routed in 3D. So the cost also reduces by using it, or purchasing excessive of cables or wires. And also as the rework is also reduced, the cost will also get reduced, which will improve the product or the project quality. Then the design process is streamlined, and also there is a seamless collaboration between different teams like electrical and mechanical teams. Also automatic schematic creations and few of the documents like terminal step, bill of materials, and design rule checks you can get to see. And also you can get the productivity in a very lesser time to market. So with this, I would like to conclude. Here I was not able to show you the complete detailed demonstration on SolidWorks Electrical. If you wish to see the or go, look into the complete detailed demonstration on this, you can just mail to my email address, which will be displayed very shortly. We can have the detailed demonstration on this. Thank you.
Thank you, Sindhu and Srishel, for sharing and showing us the solutions in terms of simulation and electrical. And I beg your pardon for taking 9 minutes more than what we had promised. So this is a lot of content in a short time, I can understand. And if you were fast, please forgive us, and you can also come back and ask us any questions and any details that are required. So to know the final roadmap, so we saw the connected engineering, where the connected engineering starts from the RFQ to your complete technical documentation and creating your marketing collaterals, everything, where every department in each and every person in the organization is connected to one another, and we follow a parallel process to save a lot of time. And the tools like the Shape XDesign, which we spoke about, but we could not see due to the time. So these tools, which gives us a greater innovation, greater degree of innovation, which we can bring into our products and design as well. So design productivity will be increased surely by a large percentage, where when we talk about SolidWorks and Beacon, we have a large number of percentage customers who are in industrial machinery and industrial equipment, who have been benefited and are being benefited by using SolidWorks solutions. It can be CAD, or it can be any of the solutions for that matter, which we have showcased today. So it will also give us a collaborative product development tools to adapt to the regulations from the start. It can be ISO or any standard industry regulations, which has to be approved. And you can also validate your designs for greater and accurate performance. Okay, and electrical and CAD collaboration, we saw how it can help us in creating better designs and better understanding the better dynamics of our complete product in terms of a machine or an equipment. So we can also build a comprehensive manufacturing documents and interactive content for training, operation, service, and marketing collateral. So this was just a brief of what you can do in SolidWorks, and there is no limit for any kind of creativity and any kind of department that is not involved and does not have a solution in SolidWorks. So with this, we come to the end of our presentation. And if there is any questions, you can post to this mail ID or info@beacon-india.com. We'll make sure that we get back to you at the earliest. And you can also call us, and this is my number. You can call me anytime, and I'll be more than glad to help you.